Good morning. My name is Mary Kane, and I am here today to walk you through some important analysis concepts. The purpose of this presentation is to review some important concepts that we can present during an interview. CRISP DM and the data analyst responsibilities. Forecast time series preparation. Main principles of data ethics. Hypothetical case. How can we handle bias in a predictive model? Regression versus classification models in predictive analysis. CRISP DM methodology for data mining. It stands for Cross-Industry Standard Process for Data Mining. CRISP DM that guides data projects from understanding the business problem to deploying a solution and consists of 6 steps. The first is business understanding, in which the data analyst works with stakeholders to define the problem, goals, and success criteria. This ensures the analysis is aligned with business needs. Next is data understanding. Here, the analyst explores the data, checks its quality, identifies missing values or inconsistencies, and gains an initial sense of patterns or issues. The third is data preparation, which is often the most time-consuming. The analyst cleans, transforms, and selects relevant data to create a data set ready for modeling. Then comes modeling, where the analyst applies the appropriate techniques, such as regression or classification, and fine-tunes model parameters. After that is evaluation. The analyst assesses whether the model meets the original business objectives and checks for issues like bias or overfitting. And finally, deployment, which involves delivering results, whether that is a report, a dashboard, or a model, and communicating the insights so they can be effectively used. Overall, the CRISP DM emphasizes that data analysis is beneficial and closely tied to business understanding, and not just technical modeling. What needs to be done before you can forecast time series? In other words, what does time series analysis involve? Before forecasting a time series, several important steps need to be completed to ensure reliable results. First, the analyst must understand the structure of the time series, including trends, seasonality, and cycles. This helps determine which forecasting methods are appropriate. Trends are usually visualized in a scatter plot, and by drawing a regression line, we can identify whether the trend is positive or negative. Seasonality refers to patterns or fluctuations that repeat regularly over the years, and the cycle refers to other fluctuations that don't meet seasonal characteristics. Second, it's important to check whether the data is stationary or needs transformation. In other words, do the statistical properties, such as the mean and variance, remain stable over time? If they don't, it may be necessary to apply transformation, such as differentiating to stabilize the series before building a forecasting model. Third, the analyst should clean the data by handling missing values, correcting errors, and addressing outliers that could misshape the forecast. Finally, the analyst selects an appropriate forecasting model and evaluates it using historical data. One of the most popular models is ARIMA model, which handles trend and autocorrelation. This model is implemented in Python using the Pandas and Matplotlib libraries. As a conclusion, time series analysis involves understanding patterns over time, preparing the data carefully, and validating assumptions before making any forecast. Data ethics, main principles. The main principles of data ethics include privacy, transparency, fairness, accountability, and security. Privacy means collecting and using data responsibly, only for legitimate purposes and protecting personal information. Transparency involves being clear about how data is collected, used, and analyzed, especially when algorithms influence decisions. Fairness requires minimizing bias so that data and models do not disadvantage certain groups. Accountability means organizations take responsibility for their data practices and decisions made using that data. Security ensures data is protected from unauthorized access or misuse. Overall, ethical data practices help build trust with users and reduce legal and reputational risks. Some recommendations for organizations include implementing strong data governance policies, providing ethic training, auditing regularly the models for bias, and limiting access to sensitive data. Hypothetical case. Imagine you are an analyst at a financial services company and you have some concerns about bias in the way a predictive model was measured. How would you raise your concerns with your manager? Make some suggestions for how to avoid measurement bias in the future. If I had concerns about bias in how a predictive model was measured, I would first gather evidence by reviewing the data sources, evaluation metrics, and outcomes across different groups. I would then raise my concerns with my manager in a constructive and professional way, focusing on the potential business and ethical risk rather than assigning blame. For example, I might explain how certain variables or sampling methods could be skewing results and affecting fairness or accuracy. To avoid measurement bias in the future, I would suggest using more representative data sets and validating models across multiple demographic segments. I would also recommend involving diverse stakeholders in model reviews and clearly documenting assumptions and limitations, and regularly monitoring model performance. This approach promotes transparency, fairness, and better decision-making. What's the difference between regression and classification models in predictive analysis? When would you use one of these models over the other? Regression and classification are two common types of predictive models, but they serve different purposes. Regression models are used when the outcome variable is continuous, such as predicting revenue, price, or demand. For example, forecasting monthly sales would typically use regression. Classification models, on the other hand, are used when the outcome is categorical, such as yes or no, approve or reject, or churn or not churn. You would choose regression when you need to estimate a numeric value, and classification when you need to assign observations to a specific category. The choice depends on the nature of the business, the question, and the type of outcome you are trying to predict. Use regression to predict how much or how many. Use classification to predict if something will happen. For questions or access to the presentation slides, please reach out at marykane.col99@gmail.com. Thank you.